Assalamu alaikum. Today we have a next question on integration. So this is a next question and integration. Question 1. So for question 1, we can see that it's just sine inverse of x squared over root 1 minus x squared. Now, what we should supposed to know there is just to determine the best technique to solve Roman 1. So today I'm gonna explain 3 scenarios that makes us to apply the trigonometric substitution. When any integral calculus falls under these 3 scenarios, then you are it is then advisable for you to apply a trigonometric substitution. Before we start calculating, one of the scenario is when you find an equation with root this solution. So when you find any equation with root of a squared plus x squared, suppose a is any number 1, 2, 3, but squared. At that moment, that number should be in square form. So when a is squared plus x squared, it is advisable here to apply trigonometric substitution. Which trigonometric substitution are we now supposed to use when we find such a scenario? Now, there's 3 identities or 2 identities of trigonometric that we look before them. One of that trigonometric identity is that it says 1 plus sine 1 minus, not plus, 1 minus sine squared theta, it gives us cos squared theta. Do you know that it is difficult for you to get the square root of 1 minus sine squared theta? But if it is possible for you to convert it to cos squared theta, then now it becomes easy for you to find the square root of cos squared theta as indicated here. Now, the second scenario, the other trigonometric identity that we normally use in integration is 1 plus tan squared theta, which is automatically sec squared theta. So for you to use trigonometric substitution, first know these 2 trigonometric identities. Now, wherever you have addition of squares, addition of squares, for example, a squared, where a is a number and x squared, then it is advisable for you to apply this trigonometric identity. So let's go back to our question. We can see our question has minus. Now, let's look the second scenario. The second scenario is when we have a squared minus x squared. The squares, can't you see the squares of 2 numbers, but the square root of a number squared minus x squared, any number being 4, but mostly these numbers are square numbers, meaning they have square roots. So if they have square roots, then let's look this scenario. Which trigonometric substitution will we use or will we substitute? We can see 1 is a square number. 1, we can find 1 is a square number, and also sine squared theta is a square number. So we take this is as maybe it could be sine x. Therefore, it could be 1 minus sine squared x. Therefore, it is advisable for we, when we find such a scenario, to use this trigonometric substitution. So we will just use, we will just consider sine. 1 minus sine squared theta, it gives us cos squared theta. So we will force this thing to appear in our root here. So finally, we will talk about the last scenario, which is now x squared minus a squared. So now is the square, we square x, then minus any number like 1. This is advisable for we now. Just go back to this trigonometric identity and take tan there. Take tan there. The other side, maybe we can say, what is sec squared theta now? If tan squared theta plus 1 equals sec squared theta. Now let's take 1 to the other side. For this identity, it will be just sec squared theta minus 1. So sec squared theta minus 1 equals to tan squared theta. Since we have such a scenario, this is a function. So the x's represent a function, and a represent any whole number, 1, 4, but mostly they are square numbers in our equations. So can't you see here, our 1 here is a square number. So wherever you find this scenario, just think about 1 plus tan squared theta is sec squared theta. But how can we come up with a function, trigonometric function minus a number? So we use that the second identity of tan. So these are the two identities that mostly are mostly used in a trigonometric substitution integrals. Now let's come and apply it in our question. So solution Roman 1. So we have been asked to find the integral of 0 to 1, so of sine inverse of x squared all over the root of what? 1 minus minus x squared dx. So let's apply the trigonometric substitution, because we have fall under one scenario. We have one of that scenario. Now we can say here, since 1 minus sine squared x, now we shall use x equals to what? Cos squared x. Then it is easy for we to find the root of 1 minus sine squared x when we substitute it here. Then so as it becomes cos squared x. Now we have to substitute x with something. Now this something is that when you find a such scenario, then we substitute x with what? A sine theta. But our a here in our function, remember, it is squared. So since a squared is given by 1 in our C, this is a now. A squared minus, just recall those three scenarios of a squared minus x squared, then a squared plus x squared, and x squared minus a squared. So since a squared now in a scenario is 1, therefore our a will be the root of 1, which is 1. Therefore we shall just substitute x with 1 times sin theta, which is just sin theta. Now let's come to our substitution now. Let's substitute x with sin theta. Therefore, let's leave alone with this first, the integral sign. We simplify this function, then we'll come and integrate later. So this is simply sine inverse of x squared all over the root of 1. Where we have x, just substitute with sine x. So sine x squared is just sine of squared theta. So since x, when we square x, then sine will be just sine squared of theta. But now what is our dx? We want to evaluate our dx from this. Change everything with x to theta now. Now let's find our dx d theta. Our dx d theta is just cos of theta. Therefore, dx it is just cos theta d theta. So far we are together here. Now let's come and substitute it here. Very simple. Just say the integral of sine inverse x squared all over the root of, remember 1 minus sine squared theta is cos squared theta. So you just write here cos squared theta, then dx is cos theta d theta. So let's simplify it. This is to be just the integral of sine inverse of x squared all over cos. Square root of cos squared is just cos. Since the square, when we square cos theta, it becomes cos square theta, and the square root of cos square theta just cos theta, then cos theta d theta. So cancel out the cos's. Therefore, we remain with just sine inverse of x squared d theta. But we can see that we have to integrate this function now from 0 to 1 in terms of theta. Now it's not in terms of x. So we have to change this x to theta. How will we manage? How can we do this? Since we substituted x to be sine theta, we currently substituted x to be sine theta. Therefore, this is very, very simple and easy. If x cosine theta, what is sine inverse of x? So theta here, we can see our theta is just the sine inverse of x. Therefore, sine inverse of x is just theta. Very simple and easy. So 0 to 1 of what? Instead we write sine inverse, just write in terms of theta, it will be just theta squared d theta. Now, can you see this is very simple? Let's use now power rule to integrate that function, whereby you just add 1 squared plus 1 is, so it will be theta power 3. So we divide by 3 plus constant c. But now, this is our now, we have already integrated. What now is needed here? What is our, how can we get theta? What is our theta now? Our theta was sine inverse of x. We can see here, our theta is just sine inverse of x. Or we can go back to our substitution. We substituted x to be a sine theta, or x to be sine theta. But our theta just sine inverse of x. Therefore, theta here cubed, it will be just sine inverse of x cubed. Substitute theta here. Our theta is sine. Now we turn this function in terms of x as it was a given. Our function was in terms of x. We have differentiated in terms of theta. Then we are supposed not to leave it like that, but substitute back to theta to x, substitute theta back to x. But we have our theta there. Our theta just sine inverse of x. Then we come and just substitute to be just sine inverse of x, then cubed all over 3 plus constant c. So from 0 to 1, just substitute sine inverse of 1, then and sine inverse of 0 with your calculator. So using our calculator now, so let's substitute x with 1, so it will be sine inverse of 1 cubed over 3. Then since constant, it will be, there's minus, therefore it will cancel out. Then minus sine inverse of 0 cubed all over 3. So let's wind up. Just shift sine of 1. What is the result? That one. Then square our answer. But your calc should be in radians. Your calc, the SI unit for angles is radians. So just use a calc in radians. Then the cube root of answer is 3.875. Then we have to divide by 3. Just divide the answer by 3. The result is 1.292. So this, it will be just 1.292. Then minus, let's shift sign so that can be sine inverse of 0 is 0. Then 0 squared 0, therefore it will be minus 0. And finally, our integrals from 0 to 1 for that function, just 1.292. Hence, solved. Let's go to our next question. Question number 2. So, question number 2 is solution for this. The solution for that question, let's write it here. So the integral from 2 to 3 of x plus 4 all over x minus 1 x plus 1 squared dx. So that is the function. As a reminder, wherever you have any function, you have been asked either to differentiate or to integrate. First step, you have to determine the technique suitable, the best technique suitable for that function. So let's look our function. Which is the best technique for you to apply? So in this function, it is difficult for we to use a U substitution technique. Wherever you have expansion function, you know that is just you have to expand that one. It's like you have been this expansion function, or this is normally a quadratic equation. Wherever you have a linear equation, you can use U substitution or any other substitution to evaluate such equation. We can use other techniques, but when it comes to such a function with a quadratic equation divided at the bottom, the quadratic equation is divided, but now we have to integrate that one. So we just use a technique by the name partial fraction. We have to apply partial fraction to simplify. Partial fraction is just to simplify that function for you to integrate it easily. We can't use any other technique because it is very difficult when you have a quadratic equation or such a function at the bottom. So when you are given a function like this as x minus a, then x plus a squared, since this is squared, we just write when it's 1 over this, we just it is mathematical correct to say 1 over this, 1 minus this, then plus 1 minus this, you just get this one. So 1 over x minus a. So we just say there's a number here, when you, not 1, but there's a number a over this one. When you add it to a number b, all over x plus a, then plus a number c all over a x plus a squared. We just come back to this. Now I would like to explain why have I written x plus a. Remember, x plus a, the LCM of x plus a, and when you have a function squared, remember the LCM of this x plus a and x plus a squared is just x plus a squared. So if you write only x plus a squared, then your work, maybe you don't know whether there was this thing, because the square root of these two is just the same. The square root, not the square root, but the LCM. The LCM of x plus a squared, is just x plus a squared. Now, what is the square root, the LCM of these three? Another scenario, x plus a cubed. If it is cubed, then meaning that the LCM, for you to find the LCM of three numbers, there's three numbers, when you find the LCM, you get just x cubed. So it will be x plus a power 1, x plus a power 2, and x plus a power 3. When you find the LCM, you just say by, for example, you are finding the LCM, you just say by x plus 1 plus a is just this, it will be 1. This one, it will be x plus a, and this one, it will be x plus a squared. By also x plus a, it will be this, it will go 1, it will be 1, that it will be 1, this one, it will go x plus a. Then finally by x plus a, finally also this one to be 1, 1, 1. That is the LCM. Then when you multiply this one, you come back to x cubed. That's what we usually apply. So let's come to our question, which said the integral of 2 to 3 of x plus 4 all over x minus 1 x plus 1 squared dx. So let's first simplify that function. So we have a function x plus 4. Leave alone with this integration sign. First, let's simplify. Then x plus 1 squared. This is, we say, is just simply write the numerator. No, don't write the, assume the numerator to be a first term. We have to write our first term, which is a all over x minus 1. There is no square anywhere. Just leave alone with it. Then we have to add b all over. Since this is x plus 1 squared, the LCM of this of two numbers, it can give us s squared r x plus 1 and plus b all over x plus 1 squared. Since the two, can you see these two functions, the inner functions are linear function. When you are given linear function, therefore you just substitute with a value. So a, b, this should be c, I'm sorry. So a, b, and c are just value like 1, are just are values like 1, 2, 3. They are not variables. So these a, b, and c are not variables. They are numbers that we are going to calculate now. But when you are given a quadratic equation inside the function, you have to write now a linear function. So you just say the number, it could be a such function like x squared plus 1, then multiplied by x minus 1. If this squared, it could be inside here. Therefore, when you reach to this function, which is here, you just, there's no need to, the LCM of this is just that one, because it's not the function squared, is this is just a term is squared. When a term is squared, that means this is just like a quadratic function. So when given that, just you write bx. If a function is in this form, just you reach here and you just say here it is squared, and this one to be, you write a linear function up there. So when you can come up with a linear function in the bottom, it is simple for you to just put a, b, and c without any variable. Now let's come, and the secret here is just to calculate the value of a, b, and c, and you'll be done with that function. So let's calculate the values of a, b, and c. We have equated this function with this one, meaning this should be equal to this. Now, so for we to evaluate this one, let's take this, you take this denominator, you multiply both sides by this, so has this denominator to go away. So when you multiply both sides by this denominator, here this side it will cancel out and it will just remain x plus 4, which gives us, when you multiply here, then this and this cancels out and will just remain with a into x plus 1 squared, then plus, when you multiply with b, so x plus 1 cancels out and it will be just x minus 1, 1x plus 1 not squared. Then we multiply this one by b. Then finally, this one will cancel out when we multiply by c, and just remain c into what? X minus 1. Now, can't you see now is in its simplest form? Let's further simplify it. X plus 4 is just equal to, so x plus 1 squared just a squared, which is a into what? Let's just write it in that form, x plus 1 squared plus, so we can expand this one, or we just decide to leave it as it is. Just leave it as it is. We can solve it as it is, times b plus c into x minus 1. Now, let's solve this one. So what you have to do here in partial fraction, in partial fractions, you just substitute with a number that when we want, we just need to remain with a, so the rest variable to be 0. Which number can we substitute so that b can be 0 and c also can be 0? So we can say, what if we substitute with 1? Let's start with 0. When you substitute with 0 here, this it will be 1 squared. When you substitute with 0, this it will be negative 1 times 1. Now this will not be 0. So we want to only remain with a and the rest to be 0. Let's leave alone with 0. Let's go to 1. When you substitute with 1, this it will be 2 squared, which is 4. When you substitute here with 1, it will be 1 minus 1 is 0. 0 multiplied by n number is 0. Then 1 here is correct. Let's substitute here with 1. When you substitute here with 1, 1 minus 1 is 0. So you can see we can let our first substitution for x to be x equals to 1. Therefore, 1 plus 4, it will be 5, equals to what? A into 4, it will be 1 plus 1, which is 2. 2 squared is 4. Then plus 0. So therefore, our a plus 0 plus 0. So therefore, our a should be, we just divide by 4 by 4, our a will be 5 over 4. Our a is 5 over 4. Let's continue. We want to remain with only b. What should we do? But we have the value of a. So we have the value of a. So we want to make a c to be 0 but b to be a number, which what should we substitute there for we to obtain that 0? So let's substitute. When we substitute with no matter here now, let's leave alone this one. What if when we substitute this one with -1? When we substitute with the -1 here, it will be just -1 minus 1, which is -2, then -1. We can take this, we can take b away by substituting -1 minus 1, which is -1, but -1 plus 1 is 0. So 0 multiplied by this b to be 0. So b here get lost by substituting x equals to -1. So b it will be 0. But this one it will be a number now. So it will be also a goes 0. So it's simple for we. So when you substitute x with -1 here, this one becomes 0. So -1 plus 1 is 0. So all of this become 0. And we remain with x equals to x plus 4. X plus 4 being what? C. -1 minus 1 is -2. So it will be -2c. Therefore, but since x is -1, so -1 minus 4 is just -3 equals to -2c. So divide by this should be +3 because -1 plus 4 is +3. Divide by -2 by -2, we just get our c being 3/2. So we have our c. So if you have a and b and c, getting b also is just simple. So if it is possible for we to make c 0 and leaving to make c 0 and a 0 and leaving b, then it's simple. When it is difficult, just substitute the values of a, b, and c to that function and get the answer. Let's try to make our c to be a value and the rest to be 0. So what substitution should we do? We want to make a c and a. We want to make our c and a to be 0. So what should we do there for them to become 0? So when you substitute with 2, it will be 2 minus 1, which is 1. This one will be x, which is 2 plus 1. So let's come and just substitute our values of a and evaluate now. When we get the value of a, b, and c, therefore it will be simpler for we to obtain the values of x. So we have our a and c. So since now here it is difficult for we to take c to be 0, c and a to be 0, but we have the values of a and b, so you can substitute with any other. So a and b, we have their values now. If you get one more than 1 and there are 3, then meaning when you substitute with any number, even if don't substitute with a number that gives us 0 now, because we have a and b. So when we substitute x, we remain with 1 unknown and we'll get it. So our aim was to remain with 1 unknown. So all of this one was to just remain with 1 unknown. Here we remained with 1 unknown, and also here we remained with c as the unknown because we substitute x with something. So let's now substitute with 2. What happens when you substitute with 2? So it will be just 2. So the function is x plus 4. The function is x plus 4. X plus 4 equals to a x plus 1 squared plus x minus 1 x plus 1. But this one is like that times b, then plus c into x minus 1. So that is our function. So we have the values of a and b. Let's put the values of a and b. Substitute x equals to 2. Any, but it take a small value of x. So 2 plus it to be 6 equals to a. We have our a being what? 5/4. So to be 5/4 of, so 2, so it will be 2 plus 1, which is 3. 3 squared is 9. Then plus, so our x is 2, 2 minus 1 is 1, 2 plus 1 is 3. 3 times 1 is 3, to be 3. Then our b was negative. Our b was negative. So it will be negative 3/2 multiplied by 3 plus our c. We don't have c, but we have our x being 2 minus 1 is 1. So 6, it will be just, we can use our calculator now to evaluate that. So it will be just 5/4. Just take 5/4. Then multiply by 9, that value, plus that value, plus minus 3/2 times 3 times 3, that value to be 6, 3/4. Then take it to the other side, it will be 6 minus that value. So just 6 minus answer to be minus 3/4. Therefore, we finally say just c equals to minus 3/4. When we put in a calculator, it will be minus 3/4. So we have the whole and all. So come back to your substitution here. Come back to this function. We said that this function, which is in our integration, is just equal to this one. So meaningly, when we put the values of a, b, and c, then we will be done with what? We will have our all function. So this function is just the same with it. So this was to simplify for easy integration. So since this function is the same as this, we will no longer use this function to determine the integrals because it is somehow difficult. So we shall use this simplest one, which is a over x. So we'll use the function a over x minus 1 to integrate from 2 to 3. So plus b all over x plus 1 plus c all over x plus 1 but squared. So let's substitute, which is the same as the integral of 2 to 3 of a. Our a is 5/4. So it will be 5/4 of what? X minus 1. So plus b. Our b is minus, so it will be minus b. So our b is minus 3/2, so it will be minus 3/2 over what? X plus 1. Then finally it will be plus c all over. Our c is minus, so it will be minus 3/4 of x plus 1 squared. Can't you see now? It's simple. So let me show now how to integrate. So we said that the integral of 1 over a is just natural log of a. Remember these integrals, yes or no? So 8/4 here is a constant. So for constant, when given a constant, the constant goes out of integration. So when you integrate, for example, let me show you how to integrate 5/4. So the integral of 5/4 over x minus 1 is just, you take 5/4 outside the function, then it remains 1 over x minus 1. So the integral, just substitute this one to be u. When you substitute this one to be u, what happens? So then just use u substitution. Let u equals to what? X minus 1. Therefore, du dx, it will be, So we are integrating in terms of x. Du dx just 1. So du here equals to dx. Therefore, now let's integrate. So it will be just the integral of 1 over u. X is equals to u over u. Du dx the same as du, so just write du. So the integral over such a function, the integral of 1 over u is just natural log of u plus c. So but u it was x minus. So this is just natural log of x minus the natural log of x minus 1. So the integral of this one is just, but the constant is here. So just write back the constant 5 over 4. So it will be 5 over 4 natural log of x minus 1. So when you find such a function that is linear, just do the same. Just do the same. Use that technique. So the integral for this one from 0, it will be just 5 over 4 of natural log of x minus 1. Then plus a constant, see, then minus 3 over 2, just the same 3 over 2 natural log of x plus 1, natural log of x plus 1. Then plus c, then minus 3 over, but this one now is squared. Let's use our substitution. Let's integrate such a function. So a function like this, 3 over 4 over x of x plus 1 but squared, you can integrate it by saying 3 over 4, take it outside, so as we remain with 1 over x plus 1 squared. Let's use substitution now to integrate what we have here. When you substitute x, so say u equals to x plus 1. Therefore, du dx it will be 1. So du dx here, it will be just equals to du. So, but we are integrating in terms of x, which is dx. So x plus 1 squared. So, but our integral was 1 over x plus 1, where x plus 1 is u. U squared equals to what? Dx. So take this up there. You can change the sign to be negative by saying just u minus 2. You take it up to be 1 u minus 2 dx. Let's integrate. So when you integrate this one, just add 1, it will be minus 1 all over minus 1. So it will be u minus 1 over minus 1, which is just equals to, but here we have already integrated, so it's just, so plus constant c. So u minus 1, so it will be just 1 divided by minus 1, just minus u raised by minus 1. But when a number, this is minus 1 u power minus 1, just, you can write it minus 1 all over what? U power 1. That's correct. So meaning, but our u was what? Our u was x plus 1. So just substitute. So finally our integral to be just minus 1 all over x plus 1. But we had the constant multiplied by our constant. We take it outside somewhere. We take it outside here. So when we take it outside, then finally you have to multiply it. So 3 over 4 multiplied by this function just equals to minus 3 multiplied by minus 1 all over 4x plus 4. Hence, this is the integral for the last function. So when you integrate this function, you just get minus 3. So it will be minus 3 all over 4x plus 4. So, but since constant plus another constant is just constant, you can further write this function being 5 over 4. You can write that function as 5 over 4 natural log 5 over 4 natural log of x plus 1 plus minus 3 over 2 natural log of x plus, this should be minus 1, that can be plus 1, then minus 3 all over 4x plus 4. So plus constant c. Since there's limits from 2 to 3, therefore a constant, when you minus with a constant, it just becomes 0. So there's no need. So substitute with 3, then substitute further with 2, then minus the 2, the upper limit minus lower limit function. So substitute with 3. So 3x minus 1 is 2. So natural log of 2, we can use our calculator. Now, let's substitute with 3. So our first fraction, let's substitute 3. 3 minus 2 minus 1 is 2. So we just key in natural log of 2 equals to 0.6. Then multiply by 5 over 4. 5 over 4. So when you multiply by 5 over 4, you get 0.8664. So this is just 0.8664 minus natural. So natural 3 plus 1 is 4. Just key in natural log of 4, which is 1.3. Then multiply by 3 over 2, which is 2.079 minus, just take, so here there's no natural log, just take 4 multiplied by 3, which is 12 plus 4. 12 plus 4 is just 16. So 3 divided by 16, just key in 3 divided by 16, which equals 0.1875 minus the function when you substitute with 2. 2 minus 1 is 1. Just key in natural log of 1 equals to 0. So therefore the whole of this function become here, it becomes 0. Let's go to this another one. So 2 plus 1 is 3. 2 plus 1 is 3. So natural log of 3 equals to 1.0. So multiply by 3 over 2. 3 out of 2. It's just 1.648. So it will be minus, but this one is minus 1.648. Then minus, substitute with 2 here, it will be 4 times 2, which is 8. 8 plus 4 is 12. So 3 over 12, just a quarter. So minus a quarter, which in decimals is 0.25. So let's put this value in our calculator and come up with the answer. 0.8664 minus 2.079 and minus 0.1875. The answer is minus 4.00. Then, but minus to be plus, so plus 1.648, which equals to what? Positive 0.2479. Then minus also becomes positive. So we have to plus that. So plus 0.25. And our final answer is 0.4979. So the integrals for that function is 0.4979. Hence solved. So kindly just subscribe my channel. It costs you nothing to subscribe. So if it seems to be helpful and you benefited from my videos, just not like it, but subscribe so as also can benefit from this. So let's help each other. I'm putting my effort to help those who follow up with my videos. So for more videos and for more integrals and other mathematics concepts, just subscribe my channel. Don't just like, but subscribe if it is helpful and you benefited from it. So thank you very much. May you have a good day and so on. So follow up with my channels. I will solve more and more problems on calculus and other math concepts. Thank you very much.